I am not a big fan of calling this warm anomaly the Blob, but it seems to hit the press all the time, so there's the Blob. Did the recent warm anomaly enter Saanich Inlet? And so I'm going to try and, I have to say that Akash asked me if I would talk about this warm anomaly a little bit at this talk 2 weeks ago. So my ideas are not very well developed in what's happening in Saanich Inlet. So I'm going to show some data, and I'd be absolutely delighted if somebody else thought this was interesting and would take it off my hands. Background then, the warm anomaly was set up because the westerly winds were disrupted in the Northeast Pacific in late 2013, early 2014. So we can see this is December 2015, surface winds and SST, but I've put in a big red arrow here to show you that the typical westerly pattern is reestablished, and with that then is the Ekman transport of nutrients to the subtropics from the subarctic Pacific. And I understand that this process is quite important. As was described by Ayres and Lozier some few years ago, that the export of nutrient from the subarctic Pacific establishes in winter a very important productive zone called the transition zone chlorophyll front, down about 30 to 35 degrees north. This area of high productivity supports a whole whack of creatures in winter, especially when coastal productivity in the subarctic Pacific is weak, is diminished. A few years ago I tried to do a little nitrogen budget for the subarctic Pacific, and I came up with this little box. And essentially what this is showing is that, that was not what I wanted, is that upwelling introduces new nutrient into the subarctic Pacific. Pacific deep water is upwelled past 1,000 meters into the water column, and that nutrient is then used in a number of ways to support what's going on in the Arctic to some degree. So all these numbers are in gigamoles of nitrogen per year, and so some of what's upwelled goes into the Arctic. Some is exported at the surface. The largest amount is exported at the surface into the subtropics, and that's what supports this transition zone chlorophyll front. And then this paper was especially talking about how the pycnocline below the surface layer in the subarctic Pacific is getting enriched in nutrients. And in my opinion, this is helping maintain the productivity of the northeast of the subarctic Pacific as the ocean is stratifying. So that was the gist of this paper. More stratified ocean, one would expect nutrient concentrations to decline over time. That is apparently not happening, and I believe it's because the pycnocline is becoming enriched with nutrients. So the ocean is mixing shallower, but it is still, the surface layer is still being renutrified. Okay, so now the warm patch really strongly established itself by very early 2014. Anomalous winds that were blowing kind of around a high pressure ridge that built in this area transported, both stopped winter cooling in the northeast subarctic Pacific, but apparently also transported some water from the south. I think that's bonded. I'll talk about that there's a mix of two things going on here. But at any rate, this is the prevalent wind direction. This is a wind anomaly that's being shown in this plot, but there are rarely winds from the south. So in fact, there was a southerly flow of winds from the subtropics up into our patch of ocean, which ended up warming a patch of water by as much as 3.5 degrees Celsius, way outside anything that had been observed in SST measurements ever. So this was a unique event, and so what I did was, understanding that this must block Ekman transport of nutrients to the south, I took a look at MODIS chlorophyll data and focused on these two patches where typically the winter productivity maximum exists. And the chlorophyll data, in my paper I show more than this, but the chlorophyll data clearly shows in winter when there should be a peak of chlorophyll here, the chlorophyll anomaly in these two patches is something 0.2 milligrams per cubic meter. At least that much loss in productivity, which is about wiping out the chlorophyll maximum. Into 2015, it looks to me, I hadn't looked at this before being asked to come here, but it looks to me like 2015 again in winter, we again had this southern flow established, and the warm anomaly has persisted then over 2 years at least, maybe still lingering around as Richard has suggested. And now we seem to be seeing the loss of productivity. This is the March-April chlorophyll anomaly from MODIS again. We seem to be seeing a loss of productivity that is again in the transition chlorophyll front, but is also extending well down the California coast. And so this is where I start paying attention to news reports about sea lion starvation and this kind of thing. And I keep expecting to see more on loss of productivity and its impact on the coast of North America. Not much has hit the literature yet. Just to take a quick look at how the warm anomaly is distributed along line P. I have to say that all the data I've used in this, I've downloaded, so I don't have a shred of my own data in this talk, I don't believe. So what a change from when I began in oceanography so many years ago, when you collected your own 20 data points or whatever, you know, tried to publish them. Now we have just so much information online, and what a treat, I tell you. In 2 weeks you can actually throw something together. So these are the line P surveys, which I was involved in for lots of years, for 20 years. And you can see then the surface warming. Richard had said he thought some of the Argo data was showing that the warm anomaly had penetrated to a depth of 200 meters. From this, it looks to me like this warm anomaly really is a surface ocean phenomenon, mostly. There are little features like this which are warming because of eddies, mesoscale eddies, not anything to do with the warm patch especially. So anyhow, you can see that this surface layer is warmed by as much as 2.5 degrees still in February 2015. The warm anomaly has come onto shore, right against Vancouver Island here. Along with the warm anomaly, there's quite a buoyant surface layer, what we'd expect, and a little bit of a loss of oxygen, but not especially. I mean, I'm going to be talking as I go on this about the buoyancy of waters, the density of waters, and oxygen. That's going to be the focus of my talk, and that's why I show these data. Okay, so as I mentioned, lots of online data. I'm going to be touching on Saanich near the end of my talk, but before then I'm going to be taking a look at Folger data off ONC and lighthouse data, satellite measurements of course, and as I say, all this data online. The anomaly as it comes to shore, first of all, I take a look at what's going on around the Folger cable site. And here I'm using both the MODIS SST data to give me a bit of a time series and seasonal averages over a broader area. And then at 25 and 95 meters, I'm showing also the Folger temperature data. And so we can see then the January data point is hidden a bit here, the MODIS January data, but there's distinct warming in January, and by February 2015, there's a warming between 2014 and 2015. Waters are 2.8 degrees warmer in this box off the mouth of Juan de Fuca. So we've really brought quite a warm water mass onshore. Next, these wonderful time series data that you can download off a DFO site show, I think, give a bit of a historical perspective, a time series perspective to this warm anomaly and how it's penetrating the coast. And so we can see here August and February data. And this has been kind of a feature of this warm anomaly that you don't see much in summer. Summer warming kind of masks what's going on. But if you look at winter data especially, then you can pick out something like this. Between 2014 and 2015, we can see 7.5 up to 9 degrees perhaps, maybe 1.5 degrees warmer waters around Race Rocks. And these are monthly average data. So it appears that the warm water mass is, and of course around Race Rocks we're looking at a fairly well mixed water column. So the surface data that you get from lighthouses is probably representing most of the water column here. It's certainly true in Harrow. So then I go to DFO. This is again Line P cruises that and Marie Robert has started to pick up. Harrow Strait is one of the stations that she routinely samples, and so I can compare now what's happening between February 2014, before warm waters entered the straits, and February 2015. And you can see through the water column now this warming that is maybe, well, yeah, 1.5 degrees, somewhere around there. There's a density difference that's quite striking between the 2 years. In 2015, this warm water mass has affected the density of the surface waters. But interestingly, I think there's not much of an oxygen signal here. 2015, the warmer waters have not really affected what the oxygen content of the waters that will then penetrate both the Strait of Georgia and Saanich Inlet. There hasn't been a loss of oxygen. If I'm not being clear, interrupt me, please. Looking then at the Strait of Georgia, deep central basin site, again ONC data. The low oxygen waters are associated with the warmest waters of the year, which also happen to be the densest waters of the year. And so we look at the seasonal pattern in basin waters in the Strait of Georgia, and warmest waters have not quite the lowest oxygen, but co-occur with the densest waters at depth. Subsequent to the turnover of the basin, or the dense water inflow of the basin, then there is a decline in density over the next year, most of the year, which must be caused by mixing from above. And I think, and some years ago, you did a bit of work showing how strong the inflow was into Georgia, didn't you? On tidal cycles, there were very vigorous. It's not you? I thought, okay, so I thought maybe. Anyhow, I suspect then, anyhow, that the re-oxygenation of the Strait of Georgia is dependent on. Remember? Yeah, you did too. Yeah, and very strong currents, right, that were coming in through Harrow. Yeah. So anyhow, so there's some energy then on the inflow on neap tides that help then mix down oxygen into the Strait of Georgia, and this is my take on things. It's a little bit different from say the Johannesson paper in 2014, where they actually try to talk about 2 turnovers of the basin in a year, 2 overturns, and I think there's one. I think the Strait of Georgia and Saanich Inlet are very much the same. That you have a late summer intrusion of dense waters, and then you've got mixing through the rest of the year with oxygenated waters coming in over the sill and penetrating to various depths. So one of the things I wanted to point out here was in 2015 how the warm waters, maximum density waters, brought in low oxygen waters, but for some months afterwards, there was no transport of oxygen back into the basin. Oxygen continued to decline for several months, to a value that is lower than what Johannesson et al. Suggested was as low as you could get in the Strait of Georgia because of mixing in Harrow Strait. So they modeled water exchange through Harrow into Georgia, and said essentially that even if you had anoxic waters coming from the open ocean being mixed in Harrow Strait and penetrating to the basin, the lowest oxygen you might expect would be about 90 micromole. And because of weak winter resupply of oxygen, we saw lower than that. And this is going to be sort of my theme. We have to pay attention to density as a mechanism for transporting oxygen into both Strait of Georgia and Saanich Inlet. Okay, so this is just recapping what I said. I don't need to dwell on this much. In summer, low oxygen waters actually are transported deep into Georgia, and then the rest of the year you have neap tide injections of oxygen that slowly mix down till you reoxygenate the basin, but decrease the density of the waters in the basin. And so that sets up again the summer overturn of Georgia. Saanich Inlet data. Here's a time series. I wanted to put the time series up to show that the warming at 100 meters that we've seen in the last 2 years of 2.3 degrees between March 2014 and December 2015, as recorded by the Venus site, has taken temperatures about as warm as we've seen in the past 50 years, but has not created a huge warm anomaly at depth. The recovery from cool to warm has been quite strong, and so I think this is evidence, I would say quite clearly, of the warm water mass generated out in the open ocean penetrating through Harrow Strait and into Saanich Inlet at 100 meters. On the bottom, this is again the Venus data that shows oxygen levels and annual cycle. You can kind of see here how weak 2015 oxygenation is, and this is something actually that the Hallam people have been talking about. They've go to the Bamberton site, station SI3, and they saw, I think, no basin overturn in 2015. Is that correct? And a buildup of hydrogen sulfide and so on. So this is the trick of interpreting what's going on at a mid-depth in Saanich. You have to understand what's happening in the basin below. And so I showed then, oops. Next thing I'm going to do is just overlay the oxygen data from the node, and show you what 2015 looks like compared to all the previous years. And we can see then that there's this extended period early in the year through January, February, of very low oxygen, some spikes, but overall this warm water mass must be weakening circulation in Saanich and reducing oxygen supply. Profiles, the profiler is out now, down Yarrow Point. And so there's 2 years of profiler data, 2015 and then 2016 in February, that show quite low oxygen. Just this 95 meter depth is just exactly right where we see the oxygen minimum zone building up to recently. So I went to the UBC data to show what 2014 looked like in February, and you can see that this area is a very active one. And I would suggest then that what we're seeing in 2015 and 16 is directly a product of the blob. So Saanich Inlet, I forgot to say, what I did want to point out here was basin warming was quite slight, 0.3 degrees perhaps, between 2014 and 15 and then 2016. So the warmer waters would have come in summer 2015, a basin overturn. It's a weak signal, and I don't understanding where waters come from to get into basins, it's not surprising to me that the warm patch out in the ocean didn't affect the basin waters that much, because a very large component of those basin waters is the upwelled waters from the California undercurrent that enter Juan de Fuca are weakly mixed in Haro Strait before entering Saanich. So that's the typical summer circulation, and winter then we allow this anoxic basin to survive because the inflow waters are fresh and don't penetrate very deeply. And there's been a little bit of talk. I wanted to make sure we remembered that the anoxic boundary sloped up the inlet. This was shown by Dick Hurlenbo many years ago, and Roberta talked about seeing that too in their data when they headed further down inlet. So as I've been mentioning, we really have to pay attention to the density of these waters that are coming into these inlets. It changes year by year, and how that controls the development of hypoxia in our coastal waters. So taking a broader look then, how might climate change increase hypoxia in BC waters and Saanich Inlet? I'd say the recent warming event is a good example of how decreasing the density of the mixed layer can result in much weaker oxygen transport in winter into Georgia and into Saanich Inlet. And this is something we should anticipate as occurring in the future. Summer upwelling appears to be strengthening. Okay, so there's some papers out that have come out recently talking about the poleward enhancement of upwelling because of the I guess the shifts shifts poleward in wind patterns, and there's some modeling effort, and I've looked at coastal data, some evidence in upwelling records that shows that upwelling seems to be increasing along the BC coast, especially further north, at the north end of Vancouver Island. I can see that quite nicely. I took a look at that because we're trying to understand how climate might impact sponge reefs. And if we end up with stronger upwelling, we're certainly going to get more low oxygen water onto the shelf. And I think in Queen Charlotte Sound, Hecate Strait, that is a serious issue for the deeper sponge communities. It's got to also have some impact on the waters we're looking at in the southern part of BC. Another issue that we have to pay attention to, I think, is as we shift from a spring freshet to more rainfall in winter, less snowpack, more rainfall in winter, how is the change in the Fraser River discharge going to affect the density of waters flowing into the straits? I'm not going to think about that too hard, except to say that's something we do need to pay attention to when we're trying to model how inlets get oxygenated. And then finally, I believe that microbial processes should be boosted as we warm basin waters. And so I think those are the thoughts I have on how going from the blob to understanding what warming of oceanic waters, how that might impact coastal waters. I think I always head towards hypoxia and thinking that is the big issue for a lot of our coastal waters. And so those are sort of my summary thoughts. I'll leave it there.
Questions from the front? Jody.
That's right. I was a little confused about the dichotomy between it just being heating in the surface layers and the fact that the water's mostly flowing out of the Strait of Georgia at the surface.
And that's right, and that's why you don't get such a strong surface signal, I'd say, but there's enough mixing in Juan de Fuca that heat gets down into the deeper waters. Not completely, but some component of it. I think that's why you see in Saanich Inlet, for example, you see the basin waters only warming by 0.3 degrees, because you haven't really manage to mix that heat down to the deep waters very well. So that's summer. So in winter, I would say because of coastal downwelling, the warmth, the anomalous warmth can come throughout the water column into Juan de Fuca. And that's probably why we're seeing a strong warming signal at 100 meters in Saanich. Because that's a product of what's being imported from the coast of Vancouver Island during a downwelling season.
Yeah, I would suspect that it's the downwelling.
That brings in the heat, yes. So thank you for mentioning that. I'd agree. Upwelling doesn't bring in much heat. Only the bit that you can mix in from surface waters. The downwelling system is probably where you're
You
transporting.
also suggested there was anomalous southerly winds, and so that would enhance downwelling.
True. Good point. Yes. Yeah. I'd agree with that.
I think those 2 CTE casts in Harrow were really quite telling. I mean, there's clearly a lot more heat coming in.
And it's mixed.
I don't know. Carroll Strait changes weekly, right? So I mean, I think that's good.
Maybe.
The timing of those casts is tricky.
Okay.
You have, if those casts were a spring or heat, they would show that kind of range. I don't know whether they were taking the setup at the same time. They would be taking whenever line decrease is heading out.
That's right. So just opportunistic.
So
Absolutely.
it's kind of.
But she's got a, if you look through the history of those casts in Harrow, you'll get a feel for how variable it is. And whether 1 degree over the entire water column. I mean, I tried to do some heat, and a slide I put together, I brought back from Seattle actually, was looking at an Argo compiled data set out in a big area of the Northeast Pacific, Gulf of Alaska. And it's a time series averaged over a huge area, showing where Frank showed the line P data showing it's very much at the surface with a few sort of patchy eddies, if you like, underneath. This time series from the Gulf of Alaska shows, or more or less, sorry, not even the Gulf, more or less right west of Vancouver Island, shows this surface signature gradually deepening over the last 2 years. I mean, it starts off the first year at 100 meters, but in the last year and a half, it's penetrated down to 150, 200 meters. It's more of a time series. It's from Argo Float.
Yeah. Do you see a seasonal difference there? Would you see downwelling, upwelling?
No, this is too far offshore. This is too
okay.
far. It's way outside of the upwelling
Yeah.
boundary.
So it's mixing down.
More questions? Okay, good. Thank
That was
you.
good. Thank you.
Yeah, no thanks, Frank.
Yeah, thanks.